So you were a pioneer of the development of confocal microscopes, a technology that has become a workhorse of modern cell biology. For the benefit of people watching who are not familiar with it, could you just briefly describe what a confocal microscope is and why it was such an important advance?
Well, in a regular fluorescence microscope, the light passes through the entire specimen. Yeah? So the response that you get comes from the entire specimen. In a confocal fluorescence microscope, the light also passes through the entire specimen, which is bad because it bleaches everywhere. And then you have a pinhole in front of a detector, usually at that time a photomultiplier, yeah? And you only look at a single point. You look at the same point that you illuminate, yeah, at the focus of that point or focus of that beam. Yeah? And in this way, the pinhole discriminates against light that comes from either the planes in front or behind the focal plane. Yeah? So you get rid of this kind of information. But you should really regard it as discrimination. Yeah? You don't get rid of it entirely, but you reduce the contribution. Yeah? And the level of contribution essentially defines the depth of field that you can look at. Yeah, so and if you do this correctly, then you actually get 3 dimensions. You have the capability to actually record data in 3 dimensions. That is basically the idea.